Hi, I am going to present to you the main features of the latest release Spark Pro 16 from the Spark Pro toolset. But first, let's summarize in a few words what Spark is. Spark is a subset of Ada, so you can compile, debug, and analyze your Spark codes with all the tools in your Ada toolchain. An essential feature of Spark is the ability to write contracts on subprogram, that is, preconditions and postconditions. If you compile a Spark program with assertions on, then these contracts are turned into runtime assertions. For example, here, a precondition failed. If you analyze a Spark program, then the same contract can be proved. For example, here, the contract of init is proved to hold for all values of the inputs. The analysis of cannot also tries to prove that there are no possible runtime errors in the program. This is why you get other messages here besides the contract. That ends my little tour of Spark. Now on to the new features in Spark Pro 16. Ghost code is a non-intrusive way to instrument your program. It is defined with the ghost aspects. Ghost code can be used to check various properties of your program. For example, here, procedures init, first work item, and second work item should be called in sequence. We can express these properties as contracts using the ghost variable state. For example, first work item should only be called when the state is init done. Then we can prove with Spark that the code correctly implements these contracts. As you can see here, as before, you can get confirmation messages from cannot on all the properties it proved. And now you can also get a summary of the analysis results in the report. Here, it shows that all checks were approved. Let's run cannot on a client unit of the previous one. It points to a call inside the evil procedure bad client. Previously, there was no choice but to analyze manually why this is incorrect. With Spark 16, we can save on brainpower, as we now get a detailed explanation from Spark. By clicking on this icon, I raise a counterexample, that is, a path and a set of values that trigger the problem. Et voila! Spark Pro 16 supports the Ravenscar profile for concurrency in Ada that ensures determinism and schedulability. When cannot is run in concurrent code, it detects all possible causes of data races and deadlocks. For example, this code defines a reader task and a writer task, which read and write a piece of data here. When cannot is run, it detects a possible data race when accessing the data from both tasks. Let's try to see. Let's run the program in which I added some printing and assertion. Indeed, it detects the data race and stops on a failed assertion here. There is a bit of luck though. With the different timing of tasks, the issue might be impossible to detect in tests and yet happen when in operation. This is why the static detection by cannot is invaluable to detect all possible data races and deadlocks. To prevent the data race, we can make data a protected object. This ensures reading and writing of the data cannot happen at the same time. Cannot indeed proves that no data race may occur in this code. This concluded my demo of the main new features in Spark Pro 16. For more details, see the Spark Pro website at www.educore.com/sparkpro.